Okay, so z-score and empirical rule, and I apologize, my dogs are outside barking. Since the z-score is the number of standard deviations from the mean, we can easily interpret for a bell-shaped populations using empirical rule. So remember, empirical rule had stated that if something was one standard deviation from let's try that again. The range of one standard deviation, the mean, was where 68% of my data would lie. Well, like I said, this is the range where I'm between -1 and 1 standard deviation from the mean. Well, if we convert that to z-scores, if I'm within 1 standard deviation to mean, then the z-score is -1 or 1. Same thing, if I'm 2 standard deviations from the mean, where 95% of my data lies, that means my z-score is either -2 or 2. And if I'm 3 standard deviations from the mean, almost all, or like I said, sometimes we're told 99.7% of my data should lie within -3 to 3 standard deviations from the mean. So just one quick example of what we would do in a situation like this. So according to the Wall Street Journal, the maximum distance from the check-in to the gate at top U.S. airports has a mean of 0.79 miles with a standard deviation of 0.42 miles. We want to know, what is the range of distance for 60% of maximum distance from gate check-in? So if you remember, 68%, that's that range that's 1 standard deviation away. So if I'm within -1 or 1 standard deviation from the mean, that means the z-score for whatever that distance is going to be 1 or -1. And I said that backwards, sorry. So -1 or 1. So if I want to figure out what is the range of distances for 68% of my data, well, we have a mean of 0.79 and a standard deviation of 0.42. So if I want to figure out those distances, well, that's going to be x is either, remember, if it's the mean plus z-score times standard deviation. So what we'll have is x is 0.97 minus 0, let's try it again. Well, there's going to be a minus, but we'll get to why it's a minus. 0.42 times that standard deviation of -1. So if I do that, then we're at 0.37. And my other option is that I'm 1 standard deviation away, so it's 0.42 instead of times -1, just 1. And that is going to be, let me see, 9, 10, 11, up, 7, 8, 9, 10, 11, 12. So that'll be 1.2 miles away. So this range here, where 68% of my maximum distances from the airport would be, I know it's a weird phrasing, would be 0.37 to 1.21 miles. Okay. So for the next part of this, I think this data is probably skewed because something weird happens with the second part, but we're going to kind of go through that because weird stuff happens with data and we need to know what to do with that, with those kind of problems. I have no idea what that is on the bottom. We want to know, what is the range of distance for 95% of the maximum distances and check-ins of the gate? So that is 2 standard deviations from the mean. So those are going to be z-scores of -2 and 2. So same thing, except now we're going to have x times 0.79 plus 0.42 times a z-score of -2, or a +2. So if we have the -2, we're going to end up with a negative 0.05. And with the +2, we're going to get 1.63. So clearly we can't have distances that are negative. So what this is really going to say is essentially you want to take that to 1. So sometimes when you're doing these ranges, it's not going to make sense for the data that you have. It doesn't make sense to have negative distances. So this is what's telling me is that my range is going to be actually not negative 0.05 miles away, but 0 to 1.63, which still doesn't seem very likely, but that's 95% of your maximum distances from check-in to gate. So in this case, this must be a really small US airport.